Hi everyone. Today, we will talk about chemical reactions. In this video, we will discuss the part 1, which is all about the relation of collision theory and chemical reactions. Chemical reaction is a process in which one or more substances, the reactants, are converted to one or more different substances, which refers to the products. Through chemical reactions, atoms rearrange from reactants to create different substances or products. Reactants are the substances that exist before a chemical reaction takes place, while the product is a new substance that is formed during chemical changes. These products or substances where chemical reaction takes place is either chemical elements or compounds. To speed up the process of reaction in chemicals, there is a need for catalyst. A catalyst is a substance that can be added to a reaction to increase the reaction rate without getting consumed in the process. They usually work by means of lowering the energy of the transition state, thus lowering the activation energy, and/or changing the mechanism of the reaction. This also changes the nature or energy of the transition state. Catalysts are everywhere. Many biochemical processes, such as oxidation of glucose and other kinds of catalysts, include acid-base catalysts and heterogeneous or surface catalysts. To provide qualitative explanation of chemical reactions and rate at which they occur is through collision theory. A basic principle of collision theory is that in order to react, molecules must collide or move toward each other. This fundamental rule guides any analysis of an ordinary reaction mechanism. Considering the elementary bimolecular reaction, let's say for example, the latex. To combine these substances, we have substance A and substance B as reactants. If the molecules of these two substances react to each other, they must come into contact with sufficient force so that chemical bonds break. We call this encounter as collision. Molecules of A and B come into contact when chemical reaction happens. They bounce off one another completely unchanged and unaffected. In order for a collision to become successful by resulting a chemical reaction, substance A and B must collide with sufficient energy to break chemical bonds. This is because in any chemical reaction, chemical bonds in reactants are broken and new bonds in product are formed. Therefore, in order to effectively initiate a reaction, the reactants must be moving fast with kinetic energy so that they collide with sufficient force to break bonds. This minimum energy with which molecules must be moving in order for a collision to result in a chemical reaction is known as the activation energy. As we know from kinetic theory of gases, the kinetic energy of gas is directly proportional to temperature. As temperature increases, molecules gain energy and move faster and faster. Therefore, the greater the temperature, the higher the probability that molecules will be moving with the necessary activation energy for a reaction to occur upon collision. Another example, if both substance A and substance B are gases, the frequency of collision between them will be proportional to the concentration of each gas. If we double the concentration of substance A, the frequency of AB collisions will double. On the same way, the doubling of the concentration of substance B will have the same effect. Therefore, according to collision theory, the rate at which molecules collide will have an impact on the overall reaction rate. However, if two molecules collide with sufficient activation energy, there is no guarantee that the collision will become successful. In fact, according to collision theory, it says that not every collision is successful, even if molecules are moving with enough energy. This is because the molecules also need to collide with the right orientation for proper atoms to line up with one another, and bonds can break and reform in the necessary fashion. For example, in gas phase reaction of dinitrogen or N2O with nitric oxide or NO, the oxygen end of dinitrogen oxide must hit the nitrogen end of nitric oxide. If either molecule is not lined up correctly, no reaction will occur upon their collision, regardless of how much energy they have. The more critical in this orientation requirement is, like it is for large or more complex molecules. So the fewer collisions there will be, that will be effective. An effective collision is defined as one in which molecules collide with sufficient energy and proper orientation so that reaction occurs. As a summary of the discussion, regarding to collision theory, there are things should be met in order for a chemical reaction to take place, such as molecules must collide with sufficient energy, known as activation energy, so that chemical bonds break. Second is molecules must collide with the proper orientation. And lastly, a collision that meets criteria number 1 and criteria number 2, which results a chemical reaction, is known as effective collision.